डस्टिंग वो पीछे का कर लिया तूने ग्रिल? हाँ, ये खिड़की ना? हाँ, कर लिया ना, क्योंकि मैं वहां कभी कभी बैठती हूँ कुर्सी लेके। किया ना? कल थोड़ा सा ये कपाट भी कर लेना। Good afternoon, everybody. This is Dr. Ayesha.butalia. Today, our topic is black box testing. This is the continuation of our previous topic on testing strategies. The previous session was on two types of testing, white box and black box testing, and we discussed in details about the white box testing, where the main topic was testing conventional applications, where we saw the different testability features, the features of the good test, the internal and the external views. Okay, basically the internal view is your white box testing and your external view is your black box testing. So when you are doing testing on your coding part, on your phases of the SDLC, software design life cycle, then basically it is internal or the white box testing. When it is on the total product, then it is the external testing or the black box testing. We also discussed about the test case design, where we need to understand what are the objectives, what is the criteria and the constraint. Then we discussed about selective and exhaustive testing, and then coming to two types of methods in software testing, white box and black box, of which we discussed about the white box testing in detail. Okay, so cyclometric complexity, you have to calculate using graph theory. Okay, just a revision. And depending upon how many graph vertices and their edges are there. So this G is for edges and V is for vertices. So on every vertices, there are a couple of edges. Okay, so we need to calculate that. And on every edge, we need to have a separate test case. Why this is performed? So that you do not ignore any of the edge and there may not be any error at the end. So to avoid having errors, it is having defects, because I told you that there is a difference between defect and error. Defect is on the coding side and error is on the client side. So this is obviously coding, white box testing, so it has to be defect. So to reduce the number of defects, if you do all the permutation combination of all the edges, that means you formulate a test case on every edge, then probably there are very minimal chances, okay, that you have defects. So for that, we first need to calculate the cyclometric complexity, and then we need to understand all the paths and there should be a separate test case for every path. So this path is nothing but this V of G. Okay. So this we all discussed in our previous lecture, and how to calculate the weight and all that. So I would recommend that if the concepts are still not clear, please go through that video at least 2 to 3 times. So we also had about loop testing. We had simple loop, nested, concatenated and unstructured. So now directly coming to our today's topic, that is black box testing. So what is black box testing? It is done on the entire product. Okay, you do not know the internal functionality. So you only know what are the requirements, what is the input, what is the output, and what are the events that are carried out. Okay, so we have 4 arrows over here. Okay, 3 are in and 1 is out. So this all is about the black box testing. So this red box is about the coding, design, analysis and coding. This is like a box for us, and it's a packed box. Okay, and you know that red is for stop. That means you can't go inside. So that red box inside is all white box testing. Whatever is outside as a product, it's called black box testing. So in black box testing, you should be clearly knowing what is the input, what are the requirements, what are the events that are going to get, and what will be the output. Now let's have black box testing. So how is functional validity tested? Okay, I just want you to read these points and just give 2 minutes to these questions and analyze by your own, because we have done a lot of topics on software engineering. So I would recommend you to just uh, give 2 minutes on this slide and analyze it. So how is functional validity tested? How is system behavior and performance tested? What classes of input will make good test cases? So obviously, the more your class diagram is accurate, the more accurate is your test cases, because on every class, you can create a test case. Okay, because every class has objects, every class has variables, every class has behavior. Behavior means functions. So if you have to test the behavior, then you have to create the test cases on every behavior. Okay, so first you need to identify that what will be the behavior, right? And what you need to test actually. So that is why this is on the second level. On the third level is the classes. Is the system functionally particularly sensitive to certain input values? So obviously you have to have some limitations on every project. So you need to identify the risk factors. Okay, so risk factors are nothing but the sensitive values as an input. How are the boundaries of a data class isolated? Okay, obviously you need to encapsulate your data. So how do you define those boundaries? What data rates and data volume can the system tolerate? Then what effect will specific combinations of data have on the system operation? So it depends upon project to project. Okay, it may not happen that data rates and data volume would be applicable to every project, but in general, data is required by every project. Okay, without data, at times it is very difficult. Only a static web page can work without data, right? And that too, also it has a data on static web page also. But then a static web page may not involve too much of data rates and data volume, okay? Because that is why it is static. So maybe on dynamic web page, on every project, there may be certain object data types, there may be tables, database. So you need to understand that what is the limitation of that particular project. So these all things you need to list down whenever you need to do the black box testing. So if a question is asked that what are the requirements and on what parameters a black box testing is done, these are all the points you need to list it out. So already we saw in our white box testing that graph was made and V of G was calculated. Similarly, for black box testing, to understand the objects, because a class has functions and variables, so that may be come into coding part. But when you encapsulate the data, the class, it becomes an object. Okay, so when you are operating on the object, you directly apply a memory to an object and you did not know the internal part as a programmer or maybe as a tester. Okay, so to understand the objects, so in black box testing, instead of getting the variables and the functions tested, you need to understand the behavior and the objects to be tested. So you can note this point. Okay, and as I always say in every lecture that you should note the highlights. So again, I'll repeat that for white box testing, you may concentrate on variables and functions. But on black box testing, you need to concentrate on the objects and the behavioral testing. So these objects are obviously connected with the relationships. So you need to identify the relationship between objects. Now in class diagram, polymorphism, overriding, overloading, inheritance, these all concepts are where the internal functions, friend function, virtual function, these are all related to internal function relationships between classes. Okay, you need to revise your OOPS concept if you're not understanding this. Okay, so the functions of one class can be related to the function of another class, maybe by friend function or maybe by inheritance or whatever it is. So that is to be tested using white box. But in black box, the objects relationship identification is actually the behavioral testing. So in this context, we consider the term objects. In the broader possible context, it encompasses data objects, traditional components, modules, and object-oriented elements of a computer software. Okay, so you can see this diagram that there is an object and now in the white box testing, there was an weight assigned to every graph. Similarly, here every object is assigned a particular weight, and that's called as a node weight. And these relationships are by directed or undirected. If it is undirected, it's a two-way parallel. Okay, it can be an undirected one way also, and in this way it can be arrowed also. So this is undirected, this is parallel, and this is directed link. So obviously in a directed link you can assign a weight. Okay, whereas in undirected, mostly assigning weight becomes a very tedious task for which you have to use approximation methods. These are machine learning methods. Of course, it's an advanced part. So there are a lot of research work going on. So to assign a weight to an undirected link, you need to identify the approximation methods, a part of advanced machine learning. If you want, you can write it down. So it comes the equivalence partitioning. So for black box, you can do the equivalence partitioning for parallel testing. Okay, so you can have your user queries. As we said, that black box testing is related to input, events, requirements, and output. So here you can have user queries, mouse picks, output formats, prompts, okay, your input and your data. Then you have sample equivalence classes. So you need to validate the data. For that, you have user supplied commands, you have file names, you have computational data, you have boundary values, and you have valid. Basically, equivalence classes is divided into valid and invalid data. Now, this as a beginner may be difficult to digest. What I can say that equivalence classes is nothing but group of interrelated data. Okay, equivalence classes is group of interrelated data. So for example, you are identifying, you have a car manufacturing company and you are identifying the data that after feedback, how many customers have given good feedback on a diesel engine car, or maybe a petrol engine car, or maybe a propane engine car. So you can have three on this particular aspect of feedback. So the parameter is engine, right? So you have to understand first the parameters. So if there is one parameter engine, there are three values in the set: propane, diesel, and petrol. So you will have three equivalence classes for the attribute engine. Similarly, if you're identifying your car database for color, so you can find out which people have opted for which color the most. So if you say that for black color, there is higher demand. For red color, there's a medium demand. For silver color, there's a low demand. So there are three colors. Suppose the car manufacturing company is manufacturing. So three colors will come to your set and you will have three equivalence classes for the attribute color. Okay. So for every attribute, you will have a particular set, and for every set item in the set, you will have a equivalence class. So similarly, there will be some valid data and there will be some invalid data. What is invalid data? Sometimes people give incomplete feedback, okay, for a particular commodity. So that incomplete feedback can be termed as invalid. Fine. So suppose even students' feedback is taken. So we see that whether the duration for which the student is given the feedback, whether that student was there in the class. So attendance is checked. Sometimes students are not available, but they just want to have a safe side, so they give feedback. Similarly, the students who have scored very well, their feedback is taken. The students who have scored very less, their feedback is taken. So all types of feedback is taken, and then through data analytics, intelligent software, one can analyze valid and invalid data. So if in human engineering, it can be, if on a smaller data, it can be done on an exhaustive and a manual approach. But when the data is too much, for example, data mining, okay, and the more the data set, the more accurate result you can get. जितना ज्यादा आप लोगों से फीडबैक लोगे, उतना ज्यादा आपको उस प्रोडक्ट के बारे में एनालिसिस करने में इजी रहेगा. You can't say that just by taking 10 people own for a car, you can invest in lakhs of rupees for manufacturing a particular color, because you may happen to have that all those 10 color or probability that all like black color. So what the decision company will take, that only black color should be manufactured. So this is not a good way. The more large data you will take the analysis, the more confidence you will become on the outcome. So for a car manufacturing company, the feedback is important to analyze कि which car color should be manufactured most. क्योंकि ऐसा नहीं होना चाहिए कि गोडाउन में एक कलर की कार पड़ी है, कोई सेल ही नहीं हो रही है, और एक कलर की कार जो है उसका शॉर्टेज हो रहा है, डिमांड है लेकिन सप्लाई नहीं है. तो ऐसा नहीं होना चाहिए. इसीलिए पास डेटा से आपको डेटा माइनिंग करके आपको मैन्युफैक्चरिंग करना है, क्योंकि मैन्युफैक्चरिंग कंपनी का बहुत बड़ा लॉस है कि अगर लाखों की कार्स गोडाउन में पड़ी है और डिमांड है कुछ किसी कलर का और हमारे पास है नहीं. So that is why this is very, very important analysis, and you should not miss it. That's why always testing is not considered very important task for a student, but for a company who is having a crores turnover, for them testing is the most important phase actually. Okay, so similarly, the way you have for non-boundary analysis, you can also have for boundary analysis. So same things will apply. The only thing is you need to identify the boundary. So you need to identify the boundary between the input and the output, because in the black box, everything is enclosed. So you need to have the boundary. So these green lines are actually the boundaries which help you to identify the in-between modules of testing. We have done what is module testing in our previous lecture. So I would recommend, if this is not getting digested, you please go through that lecture, because sometimes you have attended that session or maybe listened to that lecture 4 days back, and you are attending this session, the continuity may be not maintained. So I will recommend that you please go through this both lectures together, okay, because it's a very big topic. So at times session becomes difficult to complete in one. So in your black box testing or your white box testing, there's a comparison testing. So what is comparison testing? It is usually used in situations in which reliability of the software is absolutely critical. Okay, that is human rated. Human rated is very critical because sometimes human have emotions, and in emotions, lot of time the human doesn't understand that whether at that time what is its mood. So that is why it becomes very critical type of feedback, and the reliability is very in fact it is very unreliable, because machine, what it does, it is unemotional. It will do the testing unemotionally and it will give you the statistics. But humans get carried away. Sometimes there is groupism. Sometimes, people like the color of the car because their competitor likes that color. So, those parameters are always there. Okay, so that is why comparison testing, if it is human-based system, then it becomes absolutely critical. And we all people, top notches, we know this, that how it is interrelated. I'll just give you a 2 minutes gap. Okay, just read this slide. So coming to orthogonal array testing, we all know what is array. Okay, it is a collection of data in a contiguous manner and of a similar type, of homogeneous type. ठीक है, तो अगर array हम integer का बनाते हैं तो integer का array होता है, नहीं तो character का array होता है, नहीं तो float का array होता है. ठीक है, so it is having homogeneous data type. Homogeneous means same, and it is contiguous because if suppose first data is on memory location 2000 and it is holding character data type, and character requires 1 byte. So next data will be at 2001. Third data will be on 2002. Okay, so it will be on contiguous memory location. And it is also static, because static means you need to define how much initially you need to initialize the memory, whereas linked list is a dynamic memory allocation. It need not be memory allocated, need not be contiguous. Okay, and it can store homogeneous data type. So array, and then you are testing. Now, what is orthogonal? Okay, it's a geometry figure like a cube. Okay, like a cube. Why it is ortho? See, it is 1, 2, 3, 4, 5, 6, 7, and 8. So 4 down and 4 up. So 8. Ortho means 8. So used when number of input parameters is small and the values that each of the parameter may be taken very clearly bounded. So applications like aircraft, they are very critical applications. There we need to do exhaustive testing. But last time we saw that exhaustive testing is a very, very tedious testing. So when it comes to black box testing, an alternative method when the input parameters are small is orthogonal. So what you do actually here, you can see that, okay, this is x-axis, this is y-axis, and this is z-axis. Okay, so these points are just telling you that these black dots, that this is x-axis, this is y-axis, this is z-axis. So one input item at a time. You will take one input item. So suppose input is small. Now small is also a very debatory figure. For some people, 200 is a small figure. For some people, 200 also is a big figure. For some people, 2000 also is a small figure. For some people, 2 lakh is a big figure. So it is all depends upon your application. So basically comparatively small. And of course, in exhaustive, small means आपको उतने permutation combination करने पड़ेंगे. तो अगर आपके 8 values है तो 2 to power 8 आपके test cases बनेंगे, तो you need to take care about that, है ना? So even 8 is also a comparatively okay figure. अगर आप 2 to the power 200 test cases बनाओगे, then you need to have a software to test it. Even we have softwares where even 2 lakh data can be tested. So that is not an issue. But when orthogonal array testing has to be done, then generally the data should be comparatively small. And if there are 8 values, you need to take one value at a time. Okay, and you need to adjust in this orthogon. Now this L9 orthogonal array is, these are the phases which they are talking about. So this is a diagonal here, there is a diagonal here. Okay, and these are the diagonals here, if you can see. Right, so they are not talking about these squares, diagonals. They are talking about this upper diagonal. They are talking about this side diagonal. Okay, and they are talking about the down diagonal and this diagonal. So this is all diagonals, and that is called L9 orthogonal array. Okay, we'll just see in detail. Now this L9 orthogonal array, here you can see that there are, if there are 3 axes, okay, so 3 axes means it is 3-dimensional. So you have to calculate, you have to make 3 by 3 matrix, and 3 by 3 is equal to 9, and that's why it is called a 9 comes figure from there. Why orthogonal? Because it's a cube where you have 4 corners up and 4 corners down. Now what is this L? If you can see, there is an L-shaped formed very drastically on the upper end and the lower end. ठीक है, अगर आप यहाँ एक्सेस में भी देखते हो तो हमें L यहाँ पे मिल रहा है, L यहाँ पे मिल रहा है. ठीक है, तो इसीलिए इसको L9 orthogonal array बोलते हैं. ठीक है, और 9 इसलिए बिकॉज 3 by 3 मैट्रिक्स है. ऑर्थोगोनल इसलिए क्योंकि 4 corners up and 4 corners down. Yes, so basically in orthogonal array testing, I'll again just summarize that you need to create an array and you need to create a matrix, okay, of maybe m by n depending upon your input and output, okay, and every item in that matrix need to be tested. So matrix can be you have never heard a matrix of 200 by 200 matrix. It becomes very difficult to even manipulate memory wise and even coding wise. So that is why orthogonal array has to be done when the values are less. So if suppose you create 3 by 3 matrix, if it's a 3 by 3 matrix, there will be 9 elements. So that means there will be 9 values on 9 3-dimensional way you need to test it. Okay, so we will have a separate lecture on only orthogonal array because we need to summarize this black box testing in this session. Okay, and you can go into detail also. So you know that if you want to implement a matrix in your coding, then array is the best way to implement it. So coming to model-based testing. So coming to model-based testing, which is also a part of black box testing. Okay, so model is basically the behavioral pattern of the software and the database. So once we said that black box has to be carried out on objects, which we were discussing right now with the help of orthogonal testing. So you can have, if the number of objects is less, if the number of input is less. Okay, but another part was behavioral, which we talked about in the beginning. So for behavioral model testing, you need to use model-based testing. So what you need to do is you need to traverse the behavioral model. And how you will come to know the behavioral model? In our UML diagrams, we have studied about state chart diagrams, okay, and the activity diagrams. So basically, all the diagrams you might identify in the UML, which categorize your behavior, okay. Some categorize your interaction with the client, some with your coding, some with behavior. Okay, so if you go through a UML lecture, we have identified which diagrams are associated with behavior. So you can just find out which UML diagrams are associated with behavior. Those diagrams implementation, that means if it's a state chart diagram, and if there are 9 nodes in your state chart, so you will have 9 test cases based on your state chart, and that's called as model based diagram. So you need to just execute those test cases and compare the actual and the expected result. So this is what is expected. In testing, what happens? You need to analyze that whether what you were expecting, are you getting or not. That's called testing basically. Okay. So there is something called as software testing patterns, which is a part of design patterns. So in design patterns, you have a specific software testing pattern related to your testing module of your SDLC. Okay, and that is called as scenario testing. So you need to identify the different scenarios for your project. Okay, and that you need to test it. So those scenarios is basically that pattern. It describes a technique for exercising the software from user point of view. ठीक है, तो क्या क्या यूजर कर सकता है, सिनेरियो कैसे चेंज हो सकता है, अलग अलग रिस्क उसमें आप फाइंड आउट कर सकते हो. Okay, so you can have n number of scenarios. What that depends. Now you need to analyze, you to lead to jugglery, you need to talk to people, you need to take feedback. Then only you will be able to analyze your testing. Okay, so we will stop here. This was all about the black box testing. Okay, so we end this with the black box testing with the software testing patterns. Of course, software testing patterns is not a part of black box testing directly, but indirectly scenario-based testing is a level of black box testing. So I hope the previous session on general on testing and white box and this on black box testing might be useful to you. Thank you very much for your patience listening. This is Dr. Ayesha Butalia signing off from this session. Have a nice day.